Welcome to Garrett CompSci. This is CS Principles on Code.org, Unit 3, Lesson 6, Debugging. First, as a warm-up, your friend calls and says, "I can't get music to come out of my speakers." Write a quick list of everything you'd ask them or have them check to try to fix the problem. Well, with electronics like computer speakers, we call this process troubleshooting. And the goal of troubleshooting is to brainstorm all the potential things that could be causing the issue, and then carefully, systematically narrow down those potential issues to the actual issue so we can fix it directly. And approaching it in this way makes it less chaotic, makes it more efficient, less stressful, and probably just more likely to be successful. So when we apply this approach to fixing problems that we find in our code, we call that debugging. Carefully going through the code to find what's wrong so we can fix it directly. The reason we call it debugging is an interesting story. In 1947, the engineers of Harvard's Mark II computer were experiencing an issue. And so they went through all the physical parts of their very large computer. The computer took up an entire room, and systematically looked through the parts until they found an actual physical bug, a moth, in the parts of the computer. And they extracted it from the computer and taped it to their logbook, their notebook, and labeled it "First actual case of bug being found." And so that coined the term bug and debugging early in the history of computer science. And because of that historical link to today, the Smithsonian Museum of American History keeps this page from their notebook with the moth taped to it in their collection. So now let's start taking a look at the process of debugging and the strategies that help us do it well. First of all, there's this video that you can access on Code.org's YouTube channel or on the lesson resources in Code.org. And it's just encouraging you that debugging is a normal part of the coding process, even for experienced professionals. It doesn't mean you're a bad coder that you have to debug. Debugging is, however, a thing that you can get better at over time. You can figure out what strategies work best for you. You can change the way you code in the first place to avoid longer debugging sessions. So there's a lot you can learn about debugging and from debugging. So keep that encouragement in mind as we actually start practicing it. Debugging is the process of finding and fixing problems in code. And then there's this graphic here with 4 steps that you'll see often through the rest of the curriculum when we're doing any coding. The first step is to describe the problem. You want to describe it precisely, like in complete sentences. What do you expect the code to do? And what does it actually do? And when does this happen? Does it happen in all cases or only in certain situations? Answer that question precisely in full sentences. And that forces your brain to think carefully about those questions. And it helps you when you actually say it out loud, maybe to another person, or to yourself, or to your cat, or whatever. Then we want to hunt for bugs. We want to look for clues as to where the bug actually is. First of all, when you type your code in AppLab or in any other IDE and you run it, you will often see yellow symbols on the line numbers that indicate warnings, or red symbols next to the line numbers that indicate errors. Errors are when the code has actually broken. Some syntax, you haven't followed the rules of the language, or something broke when it was actually being run. And that red symbol will show you where the problem actually occurred. It doesn't necessarily mean that's where your mistake was, but that's where the problem actually was noticed by the computer. And when an error is produced, you'll see some text related to the error in the console that at least gives you a hint about what went wrong that caused it to fail. It, again, will give you hints at least. Sometimes it tells you exactly what you did wrong. Warnings are hints that something might be wrong about a line of code. Sometimes they're perfectly fine and you can ignore them. But if something's going wrong, look at your warnings. Then, what did you change most recently? So if things were working and you added some more code or changed something, and now it doesn't work, think about what you last changed. Then explain your code to someone else. So if you're having trouble finding the error, finding the mistake, you can just go through your code line by line or chunk by chunk and explain, again in pretty precise sentences, to someone else what each line or chunk is supposed to be doing. And sometimes that'll alert your brain to the difference between what you're actually seeing and what you're saying it's supposed to be doing. Then look for code related to the problem. So if your code is well organized, you can narrow it down to the chunk of code, the paragraph of code, that actually does the thing related to what's going on. And then try solutions. So once you think you know what's going wrong, try a small change, test it, see how it affects what's going on. Never change too much without testing your code. And then document as you go. So keep notes on what you've learned, what problems you think you've identified, strategies you used to actually find errors. You might also take notes in the text of the actual code that more clearly explains what's going on, that prevents problems in the future. Or you can just keep notes in a notebook about your growth as a coder. As a wrap-up, we'll go ahead and wrap up by looking at their extensive advice on debugging, and then we'll move over to the activity levels for this lesson. So first, keep your code clean at all times. So from the very beginning of writing a program, keep your code neat and tidy and following all the style guidelines, making it neat and readable, not just making it work. Use clear, meaningful IDs for the elements that you put on your screens. Name them for what they are so that you can look at it and know what it is. Keep your code organized in chunks. I might call this a paragraph of code that do the same thing. So you can have some code that does one particular thing that you could label it. You could say it does this particular task. And then you can leave a blank line in your code before the next chunk if you want. You can use comments to explain your code. Comments, remember, begin with a // meaning this is not really code, this is for humans. And use those to label your chunks of code. Then write code using blocks. So remember, in AppLab you can drag blocks in that give you the template of a particular statement or line of code. Start with that and then edit it as needed with the drop downs or in text mode. But if you start with the blocks that are given to you, the templates that are given to you, it'll avoid little errors in the details of writing code. Run your code a lot, every time you add a command or two. So when you do any little thing that accomplishes one little tiny task, run it. See if it does what you thought it did. And therefore you'll catch your errors earlier. you'll be able to fix them without doing much investigation work first. While you're running your code, you can use the speed slider. The little on AppLab, it's a turtle and a rabbit with a slider in between. Use that speed slider to change how quickly it runs, and you can watch as it highlights each command and does it, and you can find out what's going wrong that way. You can add extra console.log statements to get output at various places in your code. And so you can see what's actually being handled at each step, what's in your variables, what's going on in your program at various points in the code. You can strip those out later if you need to make it neat and tidy again once you've found the problem or once you've finished your project. And then use classmates and resources. Talk out these problems with a partner or a classmate. Compare your code to examples that you know work. So come back to these slides, come back to the resources available in code.org, and look at solid examples and templates, and then customize them to your particular situation. Read the documentation on various blocks. So when you go to the blocks in your toolbox on AppLab, you can hover your mouse over them, and they will give you some hints about how to properly use them. And then finally, if all else fails, hand trace your code to track what's happening. Look at one line at a time. Pretend your brain and your pointer finger are the computer, and trace your code and what it will be doing one line at a time until you find the problem. Then we have a couple pieces of vocab. Documentation is any written description of how a command or piece of code works or how it was developed. So the documentation that we can already see on AppLab is in our code toolbox. You can hover your mouse over one and this little bubble shows up to tell you what it does. And then you can click here to see more about how to properly use it, see examples, etc. And then a comment is a form of documentation that's written right into the program. So as I said, // begins a comment. And that means everything from that point on that line is ignored by the computer. It's only for the benefit of people, of humans that read the code. That's all for this lesson. I will return in the next video to explore the activity levels for this lesson. Hope to see you back. Make sure you hit subscribe, like, and comment if you haven't already to let me know how you're enjoying these videos. Goodbye.